Hi, I'm Brian, and it's my pleasure today to talk to you about Tidynote, our system for always clear notebook authoring. This is work by Lisa and also myself, Rima, and our advisors. So if you've ever used a computational notebook like Jupyter, you've probably run into a tension between trying to explore freely and figure out what you're even trying to do versus trying to keep everything clean for yourself to later understand or for showing to other people, right? So for example, here is a real world notebook and there's a bunch of cells. Some of the cells have their output below them, but if we look closer, we'll notice a couple things. So this cell down here has been completely commented out. Its results aren't needed for the final analysis, but this might be some sort of experiment that they wanted to keep around. The other thing to notice is these numbers on the left here. Jupyter lets you run your cells out of order. And so we can see that some of these earlier cells have actually been run after the later cells. So this can create a mess in your notebook's Python state, and that can cause confusion as well. All right. So now imagine this. You are working on a notebook like this. It's a complete mess. You're really deep into something, trying to figure something out. And then your PhD advisor walks in with a crowd of important looking people and says, there's my grad student. They've been doing some great work recently. Hey, can you show us your latest results? Oh no. Why me? Why today? You need clarity and you need it fast. Is it possible to have clarity while you're exploring in the notebook? Prior work has shown that there are certain users that continuously clean their notebook as they're working, but there's still not a system that targets that particular workflow. So let's think about, why is the notebook messy? Well, our hypothesis is that you have this linear ordering of cells, but some of these cells may be ready to show to other people, and other of these cells might be some kind of scratch work that may or may not be ready for other people, but maybe you want to keep it around. So our simple idea is to separate these into two parallel spaces. One is going to be your main notebook with your presentation ready work, and on the side we'll have a scratch pad for your scratch work and things you might want to keep around. And then at any time you can click the button in the middle and hide the scratch pad to just show off what you need to for other people. All right? So that's our big idea in Tidynote. We're going to take a regular Jupyter notebook and we're going to add a scratch pad on the side. So in addition to this hideable scratch pad, because there are now more places for your cells to live, there's more opportunities for confusion about your Python's runtime state. So we're also going to enforce linear execution. And then as a final convenience, we'll let you pin cells to reduce scrolling, and I'll show you what that means in a second. All right, let's look at each of these features in turn. So first of all, you can move cells freely between the notebook and the scratchpad. So here in this notebook, I'm working with a Netflix dataset, and I'm trying to figure out how many rows in the dataset have the type of movie. Now, this is pretty easy to get wrong in Pandas, and actually I do have this wrong. So I want to work on this in the scratchpad. All right, so the first thing I'll do is I'll click the button to open the scratchpad, and then to move the cell to the scratchpad, there's a button in the upper right of the cell with an arrow, and I click that and it moves it into the scratchpad. I can expand its output or hide it, and I can move the other cells as well, right? So now with this work in the scratchpad, I've actually figured out now that actually this last one here is the one I want. So you can do editing in the scratchpad as normal. And then if you decide that it's good, you can click the button and move it back into the main notebook like so. So you can freely move work between the scratchpad and the notebook as you organically move between trying to figure things out and trying to clean things up. Now our second feature is linear execution, just to make it clearer about what your notebook state is in. So in this example, in my first cell, I have x equals 0. And then in each cell after that, we're going to increment x by 1. Now first, I'm just going to move two of these cells over into the scratchpad. And then now in this second cell, if I run it, as expected, it's going to increment x, and we'll have x as 1 here. And regular Jupyter, you could run this cell many more times, and each time it would increase x by 1. So you'd get 2, 3, 4, and 5. But in Tidynote, this cell always runs off of the state of the cell above it. So it's always going to take 0 and then add 1 to it. So when I run it again, it's just going to say 1. And no matter how many times I run it, it's always going to be 1. Now for cells in the scratchpad, to figure out how what state they're going to work off of, you just follow the dotted line here, and we'll see that this cell is going to work off of this 0 here. So when I go over to the scratchpad and run this cell, it will increment 0 up to 1, and we see 1 here. Right? Now in the scratchpad, you can add more cells, so I can expand this scratch section, add another cell below this one, and it's going to work off of the cell above it. So when I increment x here, it'll be 2. Now this scratch section here below it is completely independent of this scratch section. So if we follow its dotted line, we see it's going to work off of the 0 here. So if I run this cell down here, it's going to say 1 as well. So that's the linear execution in the scratchpad. Now what happens if we change a cell? So let's go back over here to the main notebook. We'll run this, should get 2. Oops, sorry. Let's do that again. Run this cell here and get 2. And then I'll change the cell above it. And when I run that cell, the result is 5. But the cells after it now have stale results. And we indicate the stale results by graying them out. So this 2 there has been grayed out like so until I run the cell again and get the updated result, which is 6. All right, so that's linear execution where we try to align your program state with the visual structure so that there's less confusion. And then finally, as a convenience, we offer cell pinning so that you don't have to scroll as much. Right, so here, maybe I want to keep track of the number of frames or number of rows, so I can pin that cell. And over here, maybe I want to remember what are the column names in my data frame, so I can pin that cell. And now when I scroll, these cells and the results are always visible for reference. So that's a nice convenience. So with all these features now, you're deep in your work, trying to work stuff out, but you're working in the scratchpad so that when your boss walks in with a crowd of important people, you click the button in the middle, hide the scratchpad, and whew, Tidynote saved you. All right, to evaluate Tidynote, we put it in front of 13 Jupyter users for 90 minutes each, and we told them that their goal was to keep the main notebook portion as clear as possible. We gave them either one of 2 data sets, both from Kaggle, and then after a short tutorial, we gave them a particular analysis question to answer. And once they finished that, they could use the rest of the time to do an analysis question of their own or to pick from a list of questions that we had. And after that, there was a short interview. So were the tasks that they did realistic? When we looked at what they did on their free task, they did a variety of different things, such as wrangling, summarizing, plotting, modeling, and filtering, and such, which does kind of suggest that the tasks they were doing were somewhat realistic, at least for a lab study. More interesting is how they use the scratchpad. So here in orange, we have time spent in the scratchpad, and in blue is time spent in the main notebook. And when we look at the videos to try and classify their interaction pattern, we can see that some of the users took a very scratchpad-centered workflow where they did their main work in the scratchpad and would occasionally move things back into the main notebook. On the other hand, some users took a very notebook-centered workflow where they would work in the main notebook and then occasionally clean out to the scratchpad. And then there were a couple users that took a mixed strategy where sometimes their primary attention was on the notebook and sometimes their primary attention was on the scratchpad. So this kind of shows this. The scratchpad can enable multiple ways to keep your notebook tidy. Now, what about the linearity? So every time the users executed a cell, we classified whether that cell was a linear execution, meaning it was just the next cell in order, whether it was a nonlinear execution where they went back and reran a cell, or whether they had the last cell they were working on and they just kept rerunning it. All right. And you can see, first of all, that there was quite a variety of how the users were running their cells. And if we focus in particular on the nonlinear executions, we'll see that all participants except P4 ran some cells out of order. And perhaps most interestingly, none of our participants ever had to use the restart and run all feature to resolve the state confusion about their Python state. And then just as a sanity check, we took all of their final notebooks and we did use restart and run all at the end just to make sure they produced the same results, and they did. So this suggests that the linearity does support some amount of clarity in the Python notebook state. And then finally, there's a question of whether using Tidynote actually produced clear notebooks. So we took all of the cells in their final notebooks and classified whether they were necessary for the results or somehow unnecessary. And in the main notebook, it was filled with necessary cells. Now, most of our users cleaned out their scratchpad near the end of the task, but the fact that there were a few leftovers at all suggests that Tidynote does encourage clarity. All right, so this work shows how adding a scratchpad can potentially produce always clear notebooks, but you could imagine the simple idea of adding a scratchpad could apply in other cases as well. For example, in persuasive writing, you could have a thesis on one side and then a scratch area where you have different variations of supporting arguments. Or if you're in video editing, you could have your main video timeline and then different variations and experiments on the side. Or what I'm most excited about is in graphics editing, you often have all these hidden layer groups with variations and experiments that you have, and they just clutter up your layers panel. It'd be great if there was a separate space for all those variations. Okay, that's Tidynote. We took a regular Jupyter notebook and augmented it with a hideable scratchpad, linear execution, and cell pinning. If you follow this QR code, you'll find a preprint with a link to our tool. If you try to run the tool on your own, you may have to do it within the artifact itself, but it does work. And then if you have any questions, feel free to email Lisa. Thank you for listening.